But our next speaker, a really good speaker, who was actually our BSides badge designer for 2016, our first BSides that we ran, is Iggy, and his talk is Cold Case, Catch a Killer in 16 Bytes. So let's all welcome Iggy to the stage.
Thanks, Silvio. I'm guessing these work. So you'll have to be nice to me. This is the first time I've ever done anything on this scale. And someone said I was supposed to imagine the audience as all being naked, but it's okay because I can't see you anyway. So, first a bit of a disclaimer before I get into things. My employers don't have a horse in this race, as they say. This was purely a personal research project, not connected in any way to my work. I'm not a full-time forensics guy, but I enjoy a challenge. I wasn't a member of the investigative team or any organisation that investigated any alleged crimes that I'm going to be talking about. But I do have the okay from the investigations team to talk about what I'm going to talk about. And I didn't have access to anything that is directly connected to the case, so therefore I didn't have the actual device that was involved in the case. They didn't give me any inside knowledge. And there is a matter that we're going to reference which is still before the courts in South Australia, and so of course there's a presumption of innocence in the legal process. So first, my ego trip. I'm a technologist, which is just a fancy way, especially in places like Victoria, I believe, of saying that I'm an engineer without a degree. I've been involved in electronics professionally for about 40 years at various levels, and I also spent 8 years as a New South Wales cop, which is the thing that gives me the interest in this stuff. I did general duties, intel, and I was a gun-toting J2EE dev, which is a pretty scary combination, especially when things were going wrong. Probably why they made me work from home. And I'm very lucky to have a ton of SANS training, including various forensics courses, etc., under my belt. But in some ways, I didn't really need them for this, and I've had an interest in this for a long time. And as Silvio said, I'm also the crazy old dude that designed the badge in 2016. And if you think about it, back then we had 300 badges that we hand-sold, and we thought that was a good effort. And look at the thing you've got around your neck now, and that's just an awesome effort from all the crew at Pen 10. So maybe a quick round of applause for them, I reckon. So, some background. Back in about mid-2019, I got a call from a friend in law enforcement, and they asked whether I'd be interested in looking at an old-school digital camera that they were trying to recover some stuff from. They were doing a job for SA Police at the time. Apparently, they'd tried what they could, hadn't been able to recover anything, were about to pass on the bad news to SA Pol, when somebody said, "Oh, why don't we give that old bloke a call?" And there's a saying that says, once a cop, always a cop, so I absolutely jumped at the chance to get involved. So the device is a Kodak C513 digital camera. It came out about 2007. I think they started work on them a little bit before that. It's a 5 megapixel camera. It's got an SD card slot in the side of it. The typical little compact camera that was sort of popular then. What makes these interesting forensically is that they didn't need an SD memory card because they've also got 16 megs of internal Nand flash. So even if the SD card's been removed, there's a chance of finding some evidence on this sort of device. Now, 16 megs doesn't sound like a lot these days when you've probably got a single image on your iPhone or your Android device and it's like 5 megs and you're going, yeah, that's a bit pathetic. But you could fit quite a lot of stuff into 16 megs back then. So at the risk of blowing their department budget, the crew from the forensics team went out and bought a couple of identical cameras from cash converters. Sorry, Freudian slip. And they did what research they could, performed a chip-off recovery of the 16 meg NAND flash. So they did all the right things. They removed it, put it into their forensic NAND reader, took a full binary image of what was there, and then pumped it through the very, very expensive commercial tools that anybody who's done any forensic training will have come across. And they got nothing, so that's why they called me. So they sent me a copy of their binary, which again, all of this data is purely from the test cameras. So you'll see some photos afterwards that I've got, and that's just randoms that may have owned the camera before or stole the camera or whatever, however the pictures got on there. They're nothing to do with the actual case. So I was sent that binary, and I got to work using my favourite photo recovery tool, which is PhotoRec from Linux, from the test disk suite. I use PhotoRec heaps, like for all those little jobs, if you're trying to recover some pictures that are relos deleted from their camera, or, you know, like from their memory stick or something or other. And I really enjoy buying second-hand hard disks at second-hand shops as well. Don't know why. So in this case, I've got the 16 meg image selected that they'd sent me, so you can see that in PhotoRec. Then PhotoRec, like a bunch of these tools, allows you to recover all sorts of different file formats. And I was just interested in photos sort of on this occasion, so I deselected all the other ones and just left the JPEG selected and let it run, and I got nothing as well. So that's pretty comforting, really, because if it had been that easy, I shouldn't be standing here now, and they'd probably have some real issues to address internally within their professional forensics team. So the next step was to hunt around the binary to see if I could identify anything at all that might help sort of give me some idea of what was going on. So it always helps to know what you're actually looking for. Excuse me for using the notes, because I've only read this about 20 times and I'm scared I'll forget it. So I jumped onto the Wikipedia file signature page, or the magic number page. Now the magic numbers are sequences of bytes that normally they'll be unique to a particular file type, and they allow you to use those bytes to try and find those files in a binary image of some sort, whether it's a hard disk image, whether it's an in-memory image or something. And so tools like PhotoRec, I assume just about every forensic tool, use these magic numbers to try and identify the beginning and the end of particular data blocks of interest. So JPEG has 4 sets of magic numbers, the most common, and this stuff's right at the header of the file. So there's the FFD8, FFDB, and then the other ones down below it. You can see some of them, for those who are got ASCII sort of engraved into the back of their heads. It's got the 4A, 46, 49, 46, just a normal string sequence, and I'll show you what they are in a sec. So if we go to the actual Wikipedia page, this is the excerpt from it. You can see, and there are huge numbers of these, just like there were selections in PhotoRec. You can see the byte sequences there in the left-hand column, but the next column along shows you the ASCII representation of those. So if you're looking at this like as a strings dump or something or other in Linux, or just, you know, you just go type myfile.bin, it will show you these strings. You've got that Y0, YU looking character set, or the more readable, you know, JFIF or EXIF, etc. So those are the things we're looking for. So since the tools didn't find anything, it was time to have a bit of a look around myself. So jumped into a Hex Editor and started searching for one of the strings in that list, and got a hit. You can see the highlighted area, the FF, D8, FFE0, etc. So that would indicate that there was a file starting in that area of the memory. That was promising, but it's kind of weird since none of the tools would find any of this stuff. So did a search for another one of them, found another hit for a slightly different header. But again, there are like lots and lots of these. I just repeated the thing again and again, of course. So I worked my way right through the magic number list. Again, went, yeah, this is great. Like there's stuff there, but I just don't know why I can't see it. And I didn't know at that stage what sort of file system was on the device. I suspected it was probably a FAT16 or a FAT12 file system, so it would be DOS compatible. So I went looking for the file system identifier string, which in this case is the FAT12, and I found that. And you can see the what's referred to as the boot record, because this is just, even though it's the internal memory of it, the file system's set up just as if it was on a bit of removable media. So you can see that we found it. There's a jump instruction at the beginning, which is that EB0090, which is meant to be there in the boot record. And then further down, and this stuff's all, you know, on 1 million websites, so you can look up the offsets. But the file system identification string is there as well as that FAT12. So it's like, I knew it was a FAT12 file system. So and what you could also do, if I go back one, is that offset into this file, that 346890, you could then use DD under Linux, for example, set that as the offset, extract everything from there onwards, and you can try and mount it as a file system under Linux using the mount command with the -O for a loop device. I didn't do that because I thought the thing was probably corrupt anyway, since I hadn't been able to recover any images from it. So then I ran another Linux tool called Binwalk over the file and told it to extract anything it finds. Binwalk, again, it's really flash. It'll extract images, it'll extract complete file systems as well. And it's handy, let's say you've got an embedded Linux device and you've got access to the data was in flash on that. You can extract the whole file system and then remount that and look at it. And again, it found a whole bunch of JPEG and TIFF headers, but nothing was recovered. So I was feeling a bit desperate by this stage, and all this process, I let it drag on for many, many weeks, etc., as I got distracted by other things. But I sent a random email to Kodak Australia saying, I'm working on a project for someone in law enforcement as a favour, wondering if you have any info on this old 12-year-old camera. And I really didn't expect them to even reply, because lots of times they just won't, especially if you're not sending an official email from somewhere. But instead, this guy called Mark emailed me back and said they didn't have anything, but he'd pinged the US. Next thing, I had an email back from Mark. It turns out that his contact in the US had found a retired design engineer who'd actually worked on these cameras, and they're called the Red Sox, was their project name. So he gave me some basic info, which I'd already guessed at, like the fat stuff, etc., and the way the thing was structured. You can see he's got info there about the magic bytes to look for. But there was a PDF attached to it as well, which was interesting. And they'd sent me the whole engineering requirements specification for the camera. Wonderful. The fact that the Australian rep had reached out to the US was great. The fact the US had reached out to a retired engineer who'd worked on the design and was happy to help was awesome, but to send me the full technical specs was outstanding, so I was a very happy boy. So the info in both the email and the spec has confirmed that, images are saved as JPEGs, as XF 2.21. You could fit a maximum of 10 full-size images on there, on the internal storage, and that they use the common digital camera format file, so that folder structure you always see with digital cameras. And the email also confirmed that it was a FAT system, as I said. And the additional information they sent me, of course, gave me an idea of how many images I could be looking for. And if you look at the column, it says internal 16 megs, like there could be up to 41 images, deleted or undeleted, sort of hiding in this space, when someone may think that there's nothing because there's no memory card plugged in. So that was great. I passed on the information that I had so far, and then back to the forensics team, and they offered to drop off yet another camera that they bought from that business for me to examine. So again, I'm not touching real evidence in this case. So I started pulling the thing apart. Before I did that, I erased the internal memory, took some photos of some objects, deleted a couple of those, so I knew I'd have a couple of good images and a couple of deleted images, so if I did actually manage to get at the Nand contents. So I always take a ton of pictures if you pull things apart, especially consumer electronics. They've always got little catches and different size screws and a million things that you can lose. And if you want any chance at all of putting back together, just grab the phone and take lots of photos. I think I took about 20 or more photos and really got pretty distracted by the whole photo taking thing. So you see, older cameras and flashes didn't use nice, safe LEDs to light up the scene. They used these evil Xenon tubes that used a really high voltage drop rate. And the reservoir for all that high voltage nastiness is that big black 330 volt capacitor you can see in the photo, which I may have highlighted a little. You can see what's coming, can't you? In this case, I'd grabbed the camera firmly in one hand to undo some screws, and in doing so, I stuck my thumb straight across the terminals of this angry little bastard. The camera flew in one direction, I flew in the opposite direction and landed on my backside, yelling every profanity that people were kind enough to teach me in my 8 years in the cops. So, be safe, kids. Always discharge high voltage circuits. I should have known better. I used to work on TV and radio transmitters with very high voltages, and it's easy to do. So after all that excitement, we finally got to the Nand itself. So in this case, it's an STI Nand 128W blah, blah, blah. It's a 128 megabit device. This is an 8-bit device with parallel access to the data, so it's 16 megabytes, as we'd sort of said before. I still wasn't confident that the chip-off read that they'd given me was complete, and so I wanted to see whether I could read the contents of especially this particular camera myself. And I've got one of those cheap TL866 programmers that everyone seems to use. You get them on eBay. They're great for like all sorts of stuff, but no support for these as far as I knew. So I was going to do a chip off of my own. So I masked off all around the chip with the yellow Kapton tape, which is a heat-proof tape. And that's important to do because if you're going to use hot air to rework something or to remove a chip, like in this case, if you don't mask off the other areas, that hot air is going to melt the solder on all those really, really small resistors and capacitors and things that are all over it, and you're going to blow those all over your workbench. So after I masked it off, applied a bit extra flux and ran some fresh solder up the two sides of the chip, and then just used hot air, trying not to burn the something out of the boards, another mistake that people make, and removed the chip. And as you can see on the second picture, everything else looks pretty good. I didn't embarrass myself by blowing any components around the place. So then back to the data sheet to figure out what to do with it. We can see it's a TSOP48 device, just means it's very flat, wide, it has legs on both sides of it. But the memory is organised into 512 byte plus 16 byte pages. And it's a parallel interface, as I said, so all the address and data lines are multiplexed onto some shared pins. So you can see that on the middle picture, you've got some shared I/O lines, and you've got read lines and enable lines and address set latch lines and whatever else. So you've got to figure out what to do with those. So you need quite a few I/Os to be able to talk to it. And this sort of flash device is different to, for example, the ESP32 that's on your badge, where the flash is connected over SPI, which is a high-speed serial bus, so it needs a bunch of wires. So I need to find a dev board in my collection, and I decided on the TNT4, which is the bottom board with a chip on it and the USB connector. It's a blisteringly fast 600 meg ARM micro with enough I/O to do the job. I needed 15 I/O lines altogether. And it's got Arduino IDE support, which is awesome because I'm a lazy programmer. So I stuck the Nand onto a breakout board. You can buy those for all sorts of different size chips. That's that green board. And wired it all up with point-to-point wiring underneath. And from the top, it looks pretty. And as I said, there were 15 I/O lines. So then got into the process of actually writing some code to talk to it. And you send commands to the flash about whether you want to read, whether you want to write, setting up the address lines, etc., about where you want to talk to and what page you want to read. Started by trying to read the electronic signature, finally moved on to being able to read blocks of memory. That went on to a full-on dumper where I could just specify whatever range of memory pages I wanted and spit those out in Intel hex format. And this is all across a terminal in traditional Arduino style, so just the serial terminal. And so I could save that Intel hex stuff in the capture buffer and then use object copy, for example, to turn that from a hex file back into a binary. So once I had that, I took my image, which was on the left-hand side, and the image they'd sent me on the right-hand side, started doing comparisons, see if I could find the same sort of strings in there, etc. And I found all the identifying stuff about it being a codec camera, the data manufacturer, those things. I looked further down into it, found the same sort of fat structure, but the address offsets were different. And I thought that was probably because of the way I was reading it, because I was fresh to this particular memory device, a DIY reader, etc. And I wasn't too concerned. I was more interested in the fact that I had read something, I could verify the same sort of stuff with there, so I could probably play with that image. But it still didn't really show me any more about why I couldn't recover any of those actual JPEG files. So, and I tried manually going in there and file carving by hand from the file allocation tables. Remember earlier on we saw the start of where the disk image was, that EB90, etc. So I followed that through in the Hex Editor and used reference charts and went through byte by byte the file allocation tables and just kept running into garbage. So I'd confirmed that there was definitely something corrupt in there. So I went back to the Nand data sheet and started looking a little more carefully at how they'd organised things. So I was looking at the page operations for reading and writing data, and there's the stuff on the left-hand side, because they had a 256-byte page, for A, a 256-byte page for B, and then they had what they were calling a spare page with 16 bytes of data. And the commands that you send to read that data are optimised to read A, B, A, B, A, B. So when you finish reading page B, for example, the thing's automatically ready to start reading page A again to make it really quick. And I thought, what if they wanted the best performance out of this thing? And, you know, it's a fairly old device, and so they weren't using page C at all. So, using my magical C crafting skills, none of this hipster Python nonsense for me, being an old man, I wrote a small utility to read in 528 bytes, which is the 512 plus 16, and to only write out 512 bytes. And I did that for every single record until the end of the file. So effectively stripping out those 16 bytes of garbage. So this time, running it through PhotoRec, it went, oh, I've recovered something. So that was pretty good. And as Dave from EEV blog says, winner, winner, chicken dinner. Except I can't do his squeaky voice. And I have 17 pictures of random people who may or may not have owned this camera before it was sold or something or other. So again, they're not involved in the case. But that was awesome. Like, I was definitely ready to party. So I documented what I'd found, and I sent off my little C utility and stuff to the forensics team. And I was pretty excited by what I'd achieved, and I reckon they were pretty happy as well, because they could now duplicate all these results themselves. And all the email just says what I've just told you, really. It just didn't take as long. Well, probably took longer to write. So summing up, the whole process probably took me several months when I was asked if I was interested in having a look at this thing until I delivered the goods. I got distracted by shiny things, I got frustrated, I went away from it, I came back to it. They nagged me a little because I got distracted. So what did I learn? Even if you have the best tools in the world, you can only do so much. It's garbage in, garbage out, as they say. You can't be an expert in everything, especially in a busy forensics area like they are. So you can't blame them for not going down the rabbit holes I did and into the weeds of, you know, what design decisions did Kodak make to make this thing particularly quick, or at least quick enough so that customers wouldn't complain. The optimizations in the Nand design of, you know, reading pages and whatever. So when it came down to it, there was an easy answer, but sometimes you have to walk up a big hill to get to the plateau. So you're probably curious as to why I bothered spending all this time on this favour. And that's because I had nothing to lose, but other people had lost everything. So I'll leave you to have a look at that for a sec. And I still, like, you know, get the choked up thing. I believe that some critical evidence may have been uncovered in this case, and that it may be the missing piece in a long-running puzzle that they had, and that there may be a good outcome coming. As I said, this matter is still before the courts in South Australia, but perhaps it really does only take 16 bytes to catch a killer. Thank you.
A really great talk, and very persistent in what you were doing to get that great result. But a question on the Slack: what got you into hardware hacking like this to start off with?
I've always loved pulling things apart. Like, ever since I was a little kid, Dad was an engineer of the old variety and used to build gadgets and build model aeroplanes and design control systems for refrigeration things. So I always had the technical influence. I got involved with amateur radio, which is kind of a neat way of learning a bit about electronics when I was a kid. And that just sort of progressed from there, and it's a case of I've got way too many dev boards, for example, for a person to reasonably have. The whole thing we did with the badge in 2016, like, we put in a ton of work, but just that creating something or looking at something someone else has created has just always really interested me, and it's sort of what drives me, which is why I was really interested, because I wanted a challenge other than my normal day-to-day things, which may have been slightly more mundane. And that's why I said to them, yeah, I'll have a look. I had nothing to lose and only something to gain. So it's really just that interest in everything and anything.
Another question was, have you done anything with the Pen 10 BSides badge this year? And this person also commented, what a great talk as well. So I know that you posted some Twitter posts on the current badge.
I haven't done anything particularly useful with it. Recently I got involved as a beta tester for some antenna simulation software. So my head's been full of RF and testing things and other goodies. And so I jumped on and started cutting tracks and deciding to measure things because I wanted to simulate the antenna and other bits and pieces. I had enough of a chance to really have a look at all the awesome goodies that are on there because there is just so much stuff packed into the badge. It would have been inconceivable for us to consider something like that back then. Like we were going, that display is $3, can we find a cheaper one or something? So I suspect I'm going to try and do lots of goodies with it, especially because the speaker ones kindly have all the accessories on it. But so far I've just been really looking at it, doing a peer review without being part of the team, and that's nothing. I really want to make that clear. Like the stuff that I did and looked at and my comments about the design are just me going through the process of, hey, this is interesting, this is what I found. So it doesn't take anything away from all the effort and the awesome job that the guys have done with it. Fantastic.
And maybe one last question before we break for lunch. Would you have been able to pull it off without the input from Kodak, without that data sheet, do you think?
Yeah, because I was already heading down that track anyway, so I'd found the FAT12 file system by doing the search for the strings. It was just such a nice touch. And also when I called the guys at Kodak back and said, apparently this was very successful, thank you very much from the team down there, etc. They were really happy because people don't tell them usually. It's like, oh, give some information and that's it. But, so, they were really rapt. So it helped. It wasn't the tipping point, but it certainly confirmed what I thought I'd sort of discovered so far.
Fantastic presentation, Iggy. Let's all give him a great round of applause.
Thank you. Thanks a lot.